Today we're going to finish 1-4. We're also going to take a quiz, if you remember, and then we are going to do 1-5. And we still need to do our constructions on angles. So if we run behind and we don't get our constructions done today, we'll just do that next on Monday, okay? But we are definitely going to do 1-4. Then we're going to separate and take the quiz because the quiz is over 1-1 through 1-4. And I would rather take that quiz while that information's fresh before I start throwing out 1-5 information and confusing you with everything, okay? But on the quiz, there might be a couple of things that talk about these two words. So I wanted to make sure this was the only thing we didn't go over. On the quiz, there are not the harder problems that deal with this, but there are just maybe some vocabulary questions. So I wanted to make sure we went over these two before I give you the quiz. And then we're going to go ahead and do the harder examples that are in the notes as well. So starting with complementary. And again, these are two words you should have learned back in middle school. Complementary and supplementary, once again, we're dealing with pairs. How many is in a pair? 2. So complementary and supplementary, first of all, are only 2 angles. So it takes 2 angles for them to be complementary, 2 angles to be supplementary. Complementary means that they have to add to equal 90. So if you look at the pictures of A, B, and C here, which 2 angles will add to be 90? Very good, Brian. 37 and 53. So A and B, if you were to add those 2 together, they should add to be 90 degrees. Complementary angles do not have to be adjacent. Remember we talked about adjacent angles are side by side? They don't have to be adjacent, but they could be adjacent. Let's say that I had these 2 angles, 1 and 2. What does this little box mean again? It's a right angle. What does a right angle measure? 90 degrees. So would you agree that angles 1 and 2 would add to be 90 here? So if it was drawn like this, they would still be complementary, but they don't have to be adjacent to be complementary, okay? They can be just 2 separate angles that add to be 90 degrees. Supplementary is very similar. Supplementary has to add to be 180. Again, they don't have to be adjacent. Which 2 angles in the picture add to be 180? A and C. 37, oops, nope, not 37, just kidding. 53 and 127. So A and C are supplementary. Again, they don't have to be adjacent, but they could be adjacent. If I were to draw my picture like this, do you agree that 3 and 4 will add together to be 180? Okay, we learned a word for 3 and 4 last class period. What do we call 2 angles that are adjacent and form a straight line? Linear pair. A linear pair. They're adjacent. They form a straight line. They're called a linear pair. And a linear pair will always be supplementary. They're always going to add to be 180 because they're always forming a straight line. Questions on that? Okay. So then we're going to talk about these 2 words, which are different. Oh, and by the way, how many of you think you might confuse complementary and supplementary? Which one's 90, which one's 180? Okay, here's a little trick they mention in the textbook. C comes before S in the alphabet, right? And 90 comes before 180 on a number line. So if you can remember, C comes before S, 90 comes before 180. Complementary adds to be 90, supplementary adds to be 180, if that helps. Just a little trick. Okay, different. Complement versus supplement. Complementary means 2 angles that add to be 90. Supplementary means 2 angles that add to be 180. The complement and the supplement are only 1 angle, not 2 angles, but they're not 90 and 180. The complement is an angle that adds to another angle so that together they equal 90 degrees. In other words, let's say I have a 20-degree angle. What would I need to add to 20 to be 90? 70. You guys with me there? So if I say I have a 20-degree angle, 70 would be its complement. It's the value that adds to it to make it 90. Or a better definition is 90 minus your angle. I don't like saying 90 minus x because then they put a variable y in the problem and that confuses students. So I say 90 minus the angle. So you might want to change that in your notes. The complement is always 90 minus the angle. So again, if I have a 50-degree angle, what is its complement? 40, okay? 30-degree angle, what is its complement? 60. So it's whatever it takes to make it 90. It is 90 minus the angle that they give you. Same idea for supplement, except it's not going to be 90 minus the angle. It's going to be 180 minus the angle. So that is your supplement. When you see that word, think 180 minus the angle. So if I have a 100-degree angle, what is its supplement? 80. Okay, 180 minus 100 is 80. Okay, so we're going to practice on a few problems. It's going to start off easy and then gets a little bit harder. So the first one is the complement of F. Look at the picture, look at F. When you see the word complement, what are you going to think? 90 minus the angle. In this case, that's going to be 59. But immediately when you see that word complement, think 90 minus the angle. So then you're going to plug in 59 for the angle. What is 90 minus 59? 31. 31 what? Degrees. Don't forget your degree symbol. Okay, I'm going to pause real quick. I see only maybe 1 or 2 people who remembered to grab a calculator. I opened it up this morning to try to help you remember. Everybody jump up and grab a calculator today. You'll want it for your quiz anyway. When we take quizzes and tests, you will not be allowed to use your own calculator. You will have to use one of mine. You can practice with yours if you want to, do your homework with yours, but when it's test time or quiz time, you have to use one of mine. So make sure you grab one of mine, even if you have your own, okay? Heads up, I just got an email too. We officially get to start tutoring next week. So if you've seen the signs down the hallway, we have Monday after school tutoring. We have Thursday after school tutoring. Those last until 4:45. You can come right after school, stay as long as you need to stay, and then leave. You don't have to stay till 4:45 if you need to leave before then, but the teacher will be there until 4:45. Wednesday mornings, bright and early, I'll be here at 7 o'clock. So if you want to come in at 7 o'clock on a Wednesday morning, that's an hour and a half before school starts that we can have some extra one-on-one time to work on whatever you need help with, okay? So just keep that in mind. I'll send out remind messages and emails to your parents to let them know as well. But that's a great way to get some extra help without having to pay for it. Free tutoring Monday and Thursday after school and Wednesday mornings. Okay, Part B. What do you notice is different on Part B? Okay, there's an X. There's an expression for the angle. So my first information I would tell you is when you see a problem like this, if there's an expression for your angle and they're asking you for the supplement of the angle, you're probably going to end up with an expression for your answer, meaning you're still going to have a variable in your answer. So don't think that means you have to solve for X. Different than the homework where you had expressions that was due today, and in those expressions you actually had to solve for X, okay? But on this problem, if it just says find the supplement of G, all we're going to do is use our definition for supplement. What do I write down to start with? 180? It's not just 180. Supplement does not mean 180. What does supplement mean? Let's go back. What are we writing down for the definition of supplement? 180 minus the angle. Supplement does not mean 180. Complement does not mean 90. Complement means 90 minus the angle. Supplement means 180 minus the angle. You can't just write down 180. So it's 180 minus the angle. Okay, what is our angle in our picture? Okay, be very careful when you plug it in. In Algebra 1, did your teachers tell you that when you plug in something, you should put it in parentheses? It's very important that you do that. Here's why. If I don't put this in parentheses when I plug it in, it's going to look like this. right? If I put it in parentheses, 180 minus, and then I plug in all of this for my angle, what is that going to tell me to do with this negative symbol? Distribute. That means this 10 is not going to be a positive 10 once I distribute. What is this 10 going to be? A negative 10. So if you don't put it in parentheses, you're going to get it wrong because you're going to have a positive 10 when you should have had a negative 10. So best rule in Algebra 1 is when you're substituting something in, always put it in parentheses, and that way you won't make that mistake. So we have 180 minus our 7x minus 10. Okay, there's no equal sign. We don't have an equation. We're not solving for x. We're just simplifying. What can we combine here to simplify? Very good. Negative 10 and 180. What is 180 and negative 10? 170. So this would be 170 minus 7x. And that's as far as you can go. There's nothing else you can do. You don't have an equation, so you can't start dividing or multiplying. That's what you do if you have an equation because you do it to both sides. We don't have an equation. We just have an expression. They're not like terms, so we can't simplify them. So the supplement of angle G would be 170 minus x. You guys with me here? This will be on not your quiz, but on your test when we take the test over the chapter 1. So it's important you understand what we did there. And then think about it. What did we say an angle plus its supplement should always equal? What does an angle and its supplement always add to equal? 180. So look at what we have. Our angle, 7x plus 10, plus our supplement, 170 minus 7x. Combine like terms there, what's going to happen with this 7x and this negative 7x? They cancel out. And then what is 10 plus 170? 180. So you know you did it correctly if your two values, add to be 180. Does that make sense? Okay, so complement, 90 minus the angle, supplement, 180 minus the angle. All right, but complementary means two angles that add to be 90. Supplementary means two angles that add to be 180. Last example we need to do that we didn't do is the hardest one. And I'm going to go ahead and do this one. Your homework questions will probably be a little bit easier than this one, but let's go ahead and do this one together. So read it first. Okay, how many of you think that's kind of wordy and you're kind of like, oh, I have no idea what to do? All right, so we're going to work through this. I'm going to show you two different ways you could work the problem. For those of you who are more algebra brained, you want to dissect the sentence, write an algebra equation, we'll do it that way. For those of you that are more geometry, you want to see a picture, it helps you to see the picture, we'll do it that way. And then you can decide what works better for you. So when I teach Algebra 1 and we have word problems, I teach my students to look for key words like is, plus, times, less than, more than. Those are key things that help us think about what mathematical operation should we use. Then, when we don't know what something is in algebra, what do we call it? If you have an unknown value and you don't know what it is, what do you put in its place? A variable, x, any variable that you want. So as we read through this, we're going to look for those key words and try to translate things we don't know to variables, and then look for those key things that would be mathematical symbols or numbers. So an angle. Do we know what the angle is? No, so what can we call it? X. Is. An angle is. What does that mean we should put there mathematically? What does is mean? Equals. An angle is this, so an angle equals this. So when you see that keyword is, think equals. Okay? 10 degrees more than. What's that going to tell me to do? Add 10. So if I have $5 and you have $10 more than me, how much do you have? 15, because you added 10. So 10 degrees more than means we're going to add 10, but we're going to add 10 to whatever this says, right? 10 degrees more than this. So I'm going to leave a blank here because we're going to put something there, and then I'm going to add 10 because it's 10 degrees more than something. Are we good so far? If it had said 10 degrees less than, what would I have written? Minus 10. Okay. So then we keep reading. It's 10 degrees more than 3 times. So that means I need to put down the number 3, and I need to multiply 3 by something, right? Times means to multiply. So I'm going to put parentheses here to indicate that I'm multiplying it by 3. Is that okay? Okay. It's 3 times what? The measure of its complement. We can't call the complement x because we've already called the angle x. If we put a variable y, then we have 2 variables and only 1 equation. In Algebra 1, you should have learned that you cannot solve 1 equation with 2 variables, right? You have to have 2 equations if you have 2 variables. So instead of calling it y, think about what we said the complement is supposed to be called. What do we call the complement? Not just 90. 90 minus the angle. What did we call the angle? X. We said our angle was x, so if this is 90 minus the angle, what is our angle? X. So we can just put 90 minus x. Which if you think back to what was in our notes, that's what they wrote for the complement, but sometimes that confuses students if they don't call their angle x. Then that messes them up. So I just say 90 minus the angle. Now we have an algebra equation. We can go through and solve for x. Keep in mind, though, what does x stand for? The angle. What are they asking us to find? The measure of the complement. So x is not going to be our answer, but we're going to solve for x first. Okay, what do you want to do to solve? Can't subtract 10 yet. Distribute. Always do your order of operations. Parentheses, then exponents, then multiply. So we want to do distribute within our parentheses. So x equals 270 minus 3x plus 10. Now what can we do? Like terms. So what do we have over here on the right that we can combine? 270 and 10. So we have x equals 280 minus 3x. Now what do we want to do? Good. Get our x's on one side together. So the opposite of subtraction is addition. Add 3x. And what do we have? 4x equals 280. And now what? Divide by 4. Very good. And so what is x going to equal? Oops. How about divide by 4, not x? Very good. X is going to equal 70. But again, that is the angle, right? We call it the angle x. So how do we find the complement? We subtract it from 90. The complement is 90 minus the angle. The angle was 70. So what is 90 minus 70? 20. 20 what? Degrees. Don't forget your degree symbol. Okay, now the hard part there was setting up that equation. Once you get the equation, as long as you understood your algebra last year, you're okay with solving for x. Let me show you a second way for those of you that are kind of shaky with how do I come up with that equation and see if this helps you. So what did we say an angle and its complement should add to equal? 90 degrees. So if we think about this word problem, we're talking about an angle and its complement. So what we could do is we could draw ourselves a picture, divide it into 2 angles, make it a right angle because it's complement, which means it should add to be 90, complementary. So we have the angle and we have its complement. And together those should add to be 90. Are you with me there? Okay, so now let's see if we can take this information and plug it into our picture with some expressions, maybe not a full equation yet. So if I think about what they're telling me, I have an angle that is 10 degrees more than 3 times the complement. So do we know what the complement is? Pretend we don't. So you would say, no, we don't know what the complement is. So what do we want to call the complement if we don't know what it is? X. The angle is 10 degrees more than 3 times the complement. So The complement's x. The angle is 3 times that, but it's also 10 degrees more than. You see how I got 3x plus 10? This time, though, I called the complement x. So when I solve for x, will it be my answer? Yes, because it said find the measure of the complement. What do we know about part plus part in a picture? It should equal the whole. And what is the whole angle here? 90 degrees. So what equation could I write down using this picture?
90 equals 3x plus 10 plus x.
Exactly. So if you prefer to work it that way, then you have an equation that when you're done solving is your complement for x. You have a picture to kind of relate the idea that an angle and its complement should add to be 90. You just had to come up with the expression for the angle using this part of the sentence. 10 degrees more than 3 times the complement. Combine like terms. What's 3x plus x? 4x. So 90 equals 4x plus 10. Subtract your 10. 80 equals 4x. Then what? Divide by 4. So what is x? 20. 20 degrees, which is exactly what we got for our complement doing it the other way. Okay, raise your hand if you prefer what we did on the smart board. Okay, raise your hand if you prefer drawing the picture and you like it that way. Okay, and so it's going to be whatever works better for you. Okay, I don't care at all. I just want you to be able to get the right answer. All right, we'll practice that some more on the homework, and then, of course, before the test, we'll have a review, and we'll practice it on the review before it's really a big part of your grade. Any questions on those? Okay, be careful using the word area, but you are right, it's around the outside. So perimeter means the distance around the outside, right? What is area? Okay, the space that's inside your shape. So first thing we're going to do is we're going to talk about perimeter and area, and we're going to calculate perimeter and area on some of our basic shapes. So let's see what you already remember and then what we might need to spend a little bit more time on. So let's start with a triangle and say that I have these 3 sides, A, B, and C. So if I want to find the perimeter, what would I do? Add them. So I would have A plus B plus C. Exactly. So I would just add the 3 sides, right? Perimeter is just the distance around. Does anybody know what we call this in our triangle? The height. Okay. And I'm going to switch these just so it doesn't confuse you and call this B, because you may think B stands for base. Okay. So I'm going to call that B and this side C. So what is the formula, do you remember, for the area of a triangle? That's volume of a rectangular prism, length times width times height. That's great. We'll talk about that much later this year. Very good, Dylan. 1/2 BH. 1/2 the base times the height. Do you guys remember that now? Okay, so those are a couple of things you're going to have to know for this section. Let's move on to a different shape. Let's talk about a rectangle. What kind of angles do rectangles have? Right angles. And what do we know about the opposite sides on a rectangle? They're the same and they're parallel. Very good. So if I call this the length and this the width, then this would also be the length and this would be the width, okay? So let's go back to perimeter. What would the perimeter be for a rectangle? Careful, that's going to be a formula we're going to use, but it's not perimeter. We don't multiply the sides to find the perimeter. We add them. So what would my perimeter be for a rectangle? Very good. You could say length plus width plus length plus width, but the quicker and easier way to write that formula is you have 2 lengths, so it's 2L, plus you have 2 widths, so it's 2W. Okay? But worst case scenario, if you forget that, you just add all the sides together, right? Okay, let's go to area of a rectangle. And that is what you mentioned, Michelle, is area is what? Length times width. Okay, so you multiply, just like a triangle is base times height, but you divide it in half because you're only looking for half of the shape. When you think about a triangle fitting inside of a rectangle, a triangle would be half of a rectangle, so it's half the base times the height. Whereas in a rectangle, it's the whole thing, so it is the base times the height, or the length times the width. All right, let's go to a square. What's different on a square than a rectangle? All the sides are the same, so it still has 4 right angles, but now we don't have a length and a width, we just have one side length all the way around. So I'm just going to call this S for side. So what could we call the perimeter for a square? Very good, S times 4, 4S, because we have 4 side lengths and they're all the same. What's the area formula for a square? S times S, just like length times width for a rectangle, it's going to be side times side, but what is S times S? S squared. So it's easier to write that as S squared. Okay, last one we're going to review today, see if you remember, is a circle. We don't call the distance around a circle the perimeter, we call it what? Circumference. The reason they call it a different word is because the definition actually for perimeter is the sum of the side lengths. But a circle doesn't have any sides, right? It's just one continuous curve. So we call it the circumference. What do we call this distance from the center of the circle to the side of the circle? The radius. Very good. And how many radii does it take to make one complete diameter? 2. So if we extended this across and had another radius, then the whole length would be the diameter, right? So the diameter is equal to twice the radius. Is that okay? And if they give me the diameter, what am I going to do to that number to find the length of the radius? Divide it by 2. So if I have the whole diameter and I just want one radius, I'll divide it by 2. Okay, so do you remember the circumference formula for a circle? Very good, Barrett. Diameter times pi is one way to write it, or I think I heard somebody else say. Very good. 2 times pi times r. Think about that with me. We just said that 2 r's is the same as 1 diameter, right? So you can either say pi times diameter, or you can say 2 times pi times r. Both of them will calculate the circumference. What's the area formula for a circle? I'll help you a little bit. It has a pi, it has an r, and it has a 2, but it's not 2 pi r. What is the area of a circle? Very good. It is pi times r squared. Okay, pi r squared. Okay. There is a 4 and a pi in a sphere, but it's not just 4 pi. But we'll talk about that. Yes, it is. You're right. Okay, so let's go back to your notes here. All of this information is in your notes. If you were writing it down, that's great, but it is also in your notes. If you didn't write it down, it's okay. You said perimeter was the distance around the shape. They're going to say that it's the sum of the sides. So just remember, worst case scenario, you forget a formula up here. You just add all the sides together to find your perimeter. Area is the space inside that the definition they're going to give is, it's the number of non-overlapping square units that fit exactly inside the figure or that cover the figure. And the reason that's important, I circled square units, is because I'm going to be super picky about you putting units in your answers, just like I have been so far. So I would warn you that when you're finding the perimeter, your answers are just going to have units at the end, like inches, feet, miles, whatever the units are they give you. But when you're finding area, what are you going to do to those units? Say it again. Square them. So this area will be things like inches squared or feet squared or miles squared. Okay? But perimeter will just be inches, feet, miles, whatever units they give you. biggest mistake I see on homework is students do this. They have a problem like this, and it is a square, and they say find the area, which is side squared, and so they plug in 4 and they square it, and they get what? 16, and then they do this. That is wrong. That means 16 times 16, which is much larger than 16, right? Do not square the number. If they don't give you any units, then either leave off the units, and I won't count off for that because they didn't give them to you, or you have to put the letter U for units and then square it. The number is not what's being squared at the end of the problem. Does that make sense? It's your units that are squared. So my rule is if they don't give you units, you don't have to write units. If they give you units, you have to put your units, okay? But never put a square above your answer, only above the units. Okay, here is the chart that has all of the formulas for the rectangle, the square, and the triangle that we just reviewed up here on the board. You will have to know the formulas by the day we take the test. So you will not get a formula sheet. You have to know the formulas that you need to find perimeter and area. And it's just these up here on the board, and you should have been introduced to them before you got to high school. You just may not have remembered them. Okay, base. When we talk about base, a lot of times students think base is the bottom. Base does not have to be the bottom. Base is any side of your triangle. Any side. What matters is whatever you call the base, your height has to be perpendicular to it. Perpendicular means it has to form a right angle with it. So the definition for height is it is a segment from a vertex that forms a right angle with the line that contains the base. And then they give you some pictures in your notes to explain what they mean. So again, I could call this side the base and this the height in a right triangle because they make a right angle when they meet. I can call this the base, but notice that the height has to go from the vertex straight down perpendicular to it. Over here, notice that these are dashed. Are those dashes part of the actual triangle? No. So when I'm finding perimeter, I am only adding the parts that are actually the triangle. If they give me this measurement or this measurement, I am not using those measurements for perimeter. Perimeter is just the sum of all the sides. What they're doing here is showing me that if I call this the base, I can't go from this vertex over to the base and make a right angle without extending out the base. And then the vertex straight down makes a right angle. So this would be our height, and this little distance here would be our base. And that's what we would use for the area of the triangle. Does that make sense? So sometimes your height's outside your triangle, sometimes it's inside your triangle, sometimes your height is a side of your triangle. But your base and your height have to make a right angle. Okay, I already said this. Units should be linear if you're finding perimeter. That's like inches, feet, miles. Your unit should be squared if you're finding area. Okay, so inches squared, feet squared, miles squared. Okay, we're going to do a couple problems, easy together. They start off super simple with numbers, and then they're going to throw in some algebra. So we'll do these really easy ones together. Just shout it out with me. Be careful with the directions. My other class that's already done section 1.5, there were a couple people who didn't read their directions carefully. They turned their homework in, and the homework, they read it, they said find the perimeter. They stopped reading, they found the perimeter. What did they miss? And area. So on every problem, they missed a point for area because they didn't do the entire problem. So make sure you read your directions carefully. Perimeter equals area equals. Okay, what shape do we have here? Rectangle. Perimeter formula is 2 length plus 2 width. So you're going to go and you are going to plug in those values. Again, if you forget, just add all the sides. This is 6. Don't forget the opposite side is 6. If the right is 4, then the left is 4. Plug it in. We have 2 times 6 plus 2 times 4. What's 2 times 6? 12. What's 2 times 4? 8. And what's 12 plus 8? 20. What am I forgetting in my answer? Okay, I'll do area in a minute, but what am I forgetting on the inches. Is it inches or inches squared? Just inches. Perimeter is the linear distance around, not units squared, just inches. Make sure you identify on your homework which answer is perimeter and which answer is area. So put P equals or A equals. All right, area formula. What's the area formula for a rectangle? What is it? Length times width. What's the length? 6. What's the width? And what's 6 times 4? And what are my units? Inches squared. Okay, this is stuff that I know you did way back even in elementary school, maybe 5th, 6th grade before you even got to 7th grade. Calculating perimeter and area with just numbers. So they start there to make sure you remember how to just plug things into a formula. And now we're going to go to problems where there are some algebraic expressions. Oops. I messed it up. Okay, here we go. So this is the next question on your notes, right? It says find the perimeter and the area of each figure. So let's start with perimeter. What do we do to find the perimeter of the triangle? Just add all the sides. So we're going to add x plus 4 plus 6 plus 5x. And we're just simplifying our answer. So what can we combine there? X and 5x to get 6x. What else can we combine? It's 4 and 6, and we get 10. So the answer is just 6x plus 10. Didn't say solve for x. You're not trying to go back and plug x in. You're just finding the perimeter with an algebraic expression. Does that make sense? Do they give me units? No. So you can leave them off, or you can write the word units or put a U. Area. Notice it says both. What's my formula for area for a triangle? One half base times height. Okay, what's the base in the picture? 6. What's the height in the picture? X plus 4. All right, so now we have to make sure you can work with your algebra skills. Remember, when you're multiplying, you multiply from left to right, order of operations, PEMDAS. It's multiply and divide from left to right. So we start here. What's half of 6? 3. And we still have this parentheses for x plus 4. Remember, if you don't put those parentheses when you substitute it in, you're going to mess yourself up. What does this tell me I need to do with the 3? Distribute. So what is 3 times x? And 3 times 4? 12. So the area should be 3x plus 12. Again, they didn't give me units. If they did, I would have to put the units and square them. Otherwise, you can just leave them off if they don't give you units. Questions so far? Okay, let's keep going. So now we're talking about the circle. We already reviewed these words. You guys knew this very well. The diameter is the segment that goes through the center and touches both sides of the circle. So that's what we have here for the definition of diameter. The radius goes from the center to the side, so it's only half of the diameter. And the circumference is the distance around the circle. And they give you a picture here, just like I drew up on the board. Any questions about the definitions for those? Okay. So again, here's your formulas that you gave me up on the board for circumference, and then I had to help you with area, except we finally got there. So circumference, you have two options, either pi times diameter or 2 pi r, and then your formula for area, pi r squared. Most common confused formulas are circumference and area because they both have a pi, they both have an r, they both have a 2. It's where you put that 2 that makes all the difference in the world. I remember it as area is always units squared, so the formula with the r squared is the area formula. The one that's 2 pi r is the circumference formula. Okay, we are not going to use 3.14. We are not going to use 22/7 for pi. Grab your calculator and make sure that you know where the pi button is on your calculator. If you are doing homework at home and you need a calculator, you can either use your cell phone, you can use your Chromebook and pull up a calculator. If you don't have your own calculator, you don't need a graphing calculator for it, you just need a scientific calculator. A lot of cell phones, if you pull up your calculator, you can just turn it sideways and that calculator turns into a scientific calculator. But you do want to use the Pi button. So I'm pulling up my calculator here so I can show you just what you're seeing there and make sure you're aware.
Teachers and students, I have new schedules for the following students. Counseling office, please send them at this time. Dalton Gray, Alex Tashida, Colin Scott, Sarah Hancock, Anthony Tanner, Santos Chavez, Octavio Balestra, Dixie Middleton, Nicole Hendren, Annie Trinidad, Maryville Santillian, Otto, Nicholas White. Please come to the counseling office for your new schedule.
Okay, so everybody found the Pi button on your calculator? It should be in blue up above this little caret symbol, which is right below the clear button. Does everybody see it in blue? To get that button, what button are we going to have to push first? The second blue button and then that caret button, okay? So here is the rule for the homework. You follow the directions in the textbook. It's that simple. If it says round your answer to the nearest tenth, you grab your calculator, you type it all in, you round it to the nearest tenth. If it says round it to the nearest hundredth, you type it in your calculator, you round it to the nearest hundredth. If you don't have a calculator and you don't have a cell phone and you don't have internet access, do the entire problem until the very end and then get in here at 8 o'clock in the morning so that all you have to do is grab a calculator and type it in and round quickly. And if you've done all the work and that's all you have left to do on the few problems that are over circles, it won't take you but just a few minutes to type those in and round, okay? Or Encore if you need to borrow a calculator in Encore. So we're going to look at this, I think it's the last example in your notes, am I correct? Okay, so we have one more example here. I'm going to pull this down real quick. It says find the circumference and area. Again, I warn you, read the directions. With a radius of 8, I would also warn you to be super careful because on the homework they may give you the diameter and you're going to have to divide it by 2 to get your radius. Then it says use the Pi key on your calculator and round your answer to the nearest tenth. We're going to practice it both ways because on the test it may say leave your answer in terms of pi. What does that mean, leave your answer in terms of pi? It means don't plug pi in on your calculator. Do all the math that you can do, but leave pi in your answer. That means you're leaving your answer really exact, not rounded, because when you plug pi into your calculator, it's going to have to round it, okay? So we're going to do both just to help prepare us for the test, but on the homework, what are you going to do? Follow the directions. Do whatever it says, okay? So here we go. Circumference. What's my formula? 2 pi r. Write it down, because every time you write it down, that's helping you memorize it. Write it down, say it, use it. What's the radius again? 8 centimeters. So we have 2 times pi times 8 centimeters. Okay? If we're leaving our answer in terms of pi, we still need to go ahead and multiply. We're just not going to multiply by pi. So we're going to do everything except pi. So what are we going to multiply here? 2 times 8. What is 2 times 8? 16. So your answer would be 16 pi centimeters. If it said leave in terms of pi. So you multiply everything, leave pi in your answer, circle it. Did the directions say leave it in terms of pi though? No, it said round to the nearest tenth. So grab your calculator, type in 16 pi, and we're going to approximate that to the nearest tenth. What do we get? One more time, say it again. 50.3, do we all agree? Okay, so we'll put 50.3 what? Centimeters. Circle it, that's your circumference. And then you have one more part to do. The next part is area. What's the formula for area? Pi r squared. What's the radius? 8. You could put 8 centimeters if you want to, because that's going to remind you that you're going to square the 8 and square the centimeters. But if it starts to confuse you when you're putting your units in your problem, then just leave them out. And remember, area is always units squared. Okay? So we're going to square the 8 and we're going to square the centimeters. What is 8 squared? 64. We're going to leave pi in our answer, but we treat it like a variable. Would you ever say x 64? No, what do you say? 64x, right? X always comes after the number. We do the same thing with pi. If we're not plugging it on the calculator, we put it after the number because we treat it like a variable. So this would be 64 pi centimeters squared. If it said leave in terms of pi, it doesn't, so we're going to round it, plug it in on your calculator, nearest 10. Okay, I'm hearing 201.1. Everybody agree? 201.1 centimeters squared. Don't forget your units if they give you units. Questions? Okay, I'm going to warn you about one more problem, and it was the bell work that I gave you last class period. You might get a problem on your homework that's like this. What shape do I have here? Square. What's the formula for area of a square? S squared. What's my side length? X plus 2. What does it mean again if it is the side length squared? What do I write on my paper to simplify that? Okay, so I have x plus 2 squared, but what do I write on my paper to change that so I can simplify it? Very good, Jacob. So I would put x plus 2 times x plus 2. Some of you made a box when we did that for bell work last class, and some of you just distributed. So remind me, what is x times x? X squared. What is x times 2? 2x. Hey, Jacob, it's not time to go. Wait, okay. I'm sorry, Jackson. Wait, okay. Distribute your 2. 2 times x is 2x. And then distribute your 2 again. What's 2 times 2? 4. What do I have to do to finish the problem? Combine like terms. Very good, Barrett. So what does this become?
X squared plus 4x.
Very good. Okay, so just be really careful. That's why I put that in bell work last class, to make sure that you could remember how to do that for algebra, okay? Homework. You already have your slip, correct?